Hey there, Math 126 students. Somebody in the discussion board is asking, in a problem where you have to find n, meaning how far out in a Taylor series you need to go in order for an error to be small enough, how do we know when we should go directly to the pattern or when we should do trial and error? And the truth is, I would always do the first three cases and then I would look for a pattern. So that's the general approach. The reason they're messaging me is they're comparing two different solutions. One solution an instructor gives for a certain problem, they go straight to the pattern. I would argue that even in that, I would do examples 1, 2, and 3 if I was stuck. This is the one where the instructor gave sort of this cheeky, quick answer. And so what I'm going to do is do this question the way I would suggest a student could do it if they don't spot the pattern. Okay, so this is my function. This is my interval. And I believe the question is part C. So the question says, here's your function. And it was based at 1. Yes, based at 1. I'm sorry, I miscopied. So this is almost identical to the homework question. So it's hard for us to ask a question like this unless it's very similar to the homework question. So you don't have to do like the solution did and spot the pattern right away, but you do need to start looking for a pattern. So I would try 1. So that means you're going to need to get the second derivative. So the first derivative is 1 over x plus 2, which is x plus 2 to the negative 1. The second derivative, which is what I'm going to write here, is negative x plus 2 to the negative 2, which is the same as negative 1 over x plus 2 squared. I'm going to slap absolute values around it, which makes this a positive. Maybe I should have just done that. And then we have a question we need to answer, which is what is the biggest this can be? What is the maximum of this? And this feels really slow, but honestly, if you can do 1, you really can then almost immediately do 2 and immediately do 3. So it is worth the time to make sure you get this right. So when is this maximum? It's going to be maximum when the denominator is smallest. When is the denominator smallest? When you put in this negative 0.5. So let's take a look at that. 1 over negative 0.5 plus 2 squared. That's going to be our m. So it's going to be 1 over 3 halves squared. So what's that going to be? It's going to be 4 over 9. And then we're going to write down the error bound. So we're going to say, and again, your goal here is not necessarily that this is going to be the answer, but we're hoping that we gain some experience. So in my head, I'm also thinking, okay, this came out to be 2 squared. This came out to be 3 squared. Okay, so the error is this. 4/9 divided by 2 factorial x minus 1 to the 2. And we know that we're going to plug in either negative 0.5 or 2.5 because they're both the same distance from 1. Either way, I think when we plug that in, it's going, well, let's do it because I don't want there to be questions on this. Let's say I plug in negative 0.5 this time. I'm going to get negative 1.5, which is negative 3 halves, and it's squared, so it doesn't even matter that it's negative. And wait a second, this was 2/3 squared. Aha! Those are going to cancel, and your error bound is 1/2. And based off of the homework, we should already be starting to have an idea because we've seen this already. Meaning in the homework, the bounds were when it was 1, it was 1/2. When it was 2, it was 1/3. When it was 3, it was 1/4. So that would be my thought. So really at this moment, I'm willing to make a guess at the pattern. So you can see I did not go to the general pattern. I just did trial and error. Okay, let's do 2 and see if a pattern starts to form. So this looks a little different than the solutions that the student, there's nothing wrong with the solutions that were given. They just went straight to the pattern because the person writing the solutions just thought their way through the derivatives. I find that hard to do without having done a few cases. Okay, the next derivative is going to be 2x plus 2. So the answer is, to the original student's question, is you should do trial and error always. Do 1, 2, and 3. Hopefully then you're done. But if not, then you'll have an idea about the pattern. So once again, I'm going to plug in negative 0.5. Once I'm in again, I'm going to get 2 over 3 halves squared. So this is just like the last one, except now it's 2 times 2/3 squared. 2/3 cubed. Apologies. Okay, so then when I do the error bound, you can see how it starts to accelerate because I've already thought through these things in the previous example. So less than or equal to, it's going to be 2 times 2/3 cubed over 3 factorial x minus 1 to the third. We're going to plug in either negative 0.5 or 2.5. They're the same distance away. Once again, these are going to cancel. Aha! So we are going to get 2 over 3 factorial, which you should know is a third. So an n is 2. And at that moment, I'm pretty ready to guess what the pattern is. But if you want to keep going, you could go to the third derivative, and you can see that a 3 is going to come down, and all the same things are going to happen. And I would say more, but this is exactly what happened in the homework. So you're going to have a 2 times 3, or a 3 factorial. You're going to have a 2/3 to the 4. You're going to have a 4 factorial. You're going to have a 3 halves to the 4. That's the same pattern you were seeing in the homework. And so it's 3 factorial over 4 factorial. A lot of people ask me about this, but this means 3 times 2 times 1. And the denominator means 4 times 3 times 2 times 1. So those cancel. So at that moment, I'm like, have we gotten down to 0.02 yet? No, we haven't. But I do know what the pattern is. So that's how these problems are going to go. You're either going to be able to do it in the first few tries, and if you're not able to do it in the first few tries, then you're going to state what the pattern is. The pattern is for n, the error bound is 1 over n plus 1. So we would like to know when 1 over n plus 1 is equal to 0.02. We actually want to know when it's the first value, when it drops below that. But that would mean 1 over n plus 1 is 2 over 100, which means, what can we say, 100 is equal to 2n plus 2. So 98 is 2n. You get n is 49. 49 is the first time when the error bound is equal to this. So if you wanted the first time that it's strictly less than, you would say n equals 50. So this worked out just like that. But the point is, you can see I didn't really use any symbols and k's there. What I did was I did 1, I did 2, I did 3, and then I spotted a pattern. So I hope that gives you a general approach to those that doesn't require, if you can see the pattern, do it right away. That's what the solutions did. But I hope that helps. So the answer is n equals 50 because it's the first time you drop below. All right.